Algebra 2, lesson 86, greater than the trichotomy and transitive axioms, and then irrational roots. So greater than, the concept of greater than is just, if one number is farther right of another number on the number line, then it's greater than. This should be a review of stuff that we've done before. We're going to be learning how to graph some values on a number line, specifically things representing the domain of a function. And we're going to be using the trichotomy and the transitive axioms. The trichotomy axiom, pretty much the word tri, or like trichotomy. Trichotomy. The trichotomy axiom? Man, I guess I've been saying this word wrong for a long time. I don't know why that never clicked in my brain. I've been calling this the trichotomy axiom for like 5 or 6 years now. Pretty sure the word's trichotomy. Huh. Okay, anyways, so this is the trichotomy axiom. It means that there's only 3 options between 2 numbers. When you pick any 2 numbers at random, the first option is that one is less than the other. The second option is that they are equal. And the third option is that one is greater than the other. So 3 options. Now the transitive axiom is a corollary of the trichotomy axiom. Trichotomy. I want to say trichotomy. Anyways, the trichotomy axiom, which is that if one of these is true, then the other 2 are not true, right? So if we know that A is greater than B, then A cannot be less than B, and it cannot be equal to B. And then the other thing is that can translate into other things. For example, so transitive is translating. So for this one, if we say A is greater than B and that B is greater than C, then we can say that since A is bigger than B, then A is also bigger than C, right? And then same thing here. If A is less than B and B is less than C, then A is also less than C, right? So it's like an all-encompassing thing that is just including, multiple inequalities to give you an answer. Now let's talk about graphing these. So the way they're going to write these is they'll give you an inequality. Like right here, the inequality they give you is that x is not less than or equal to -4, and that the domain is equal to negative integers. Right? So we can only use negative integers. We have to graph this inequality, and we also have to figure out what this actually means. So if x is not less than and it's not equal to, the only option left is greater than. So trichotomy axiom. 2 of the 3 possibilities have been eliminated, only 1 possibility remains. So the actual inequality we're graphing is that x is greater than -4. So then we go to our number line and we're going to go to -4. Now before we draw our circle or our arrow, the domain limits us to negative integers. So I'm not at -4, so I can draw an open circle at -4, but I don't actually have to. The only values I can actually use are -3, -2, -1. This is going to be the limit of my graph because I have to use integers, which means I can't draw a solid straight line, and it has to be negative integers, which means that everything from 0 on is not allowed. So this is my answer right here. Let's do another one. This one's a little bit of a weirder example. For this one, we have that -x plus 4 is not greater than +2. The domain equals the set of real numbers. So this means that anything is fair game. Now, I have to solve this inequality. First, I have to fix it. So if it's not greater than, then the possibilities are less than or equal to. So I've only eliminated one of the 3 possibilities, so the other 2 are possible. I also have to solve by subtracting 4 from each side. So now I've got -x is equal to, or is less than or equal to -2. And then the last thing I have to do is I have to get rid of that negative, right? Because I can't graph a negative number. So if I'm going to get rid of the negative, what happens here is anytime you multiply an inequality by a negative number, the sign switches. So if I, or divide, so if I divide by -1 and I divide by -1, what happens is this sign is going to reverse. So what I'm graphing now is that x is greater than and equal to 2. All right, and then my domain is all real numbers. So I will draw my graph. I will go to +2. I'm going to draw a closed circle because it can be equal to it, and then line and an arrow going to the right. All right, that's it for graphing inequalities. So there's a lot of rules here that we should have learned in the past and that we should be remembering. The main ones are that if your graph can be equal to the number, you put a closed dot on the number. If your graph is not equal, use an open circle. Your domain limits you. If your domain is integers, you have to use dots at each integer. If your domain is reals, then you can go ahead and draw a straight arrow. Greater than, arrow to the right. Less than would be arrow to the left. And that's pretty much all of that. Last thing we're going to talk about are irrational roots. So, last lesson we talked about what to do if we have to solve two systems of nonlinear equations, right? And now we're going to find out what to do when our roots are irrational. So last time I showed you guys how to use zero-factor theorem to solve one of these problems. Now we're going to cover what happens if zero-factor theorem does not work. So again, we can't use elimination to solve these. We're going to have to use substitution. So I will rewrite this bottom equation by adding x on each side. Y is going to equal x plus 1. Okay. Once I substitute that into this equation, I have x squared plus x plus 1 squared equals 9. X plus 1 squared is going to give me x squared plus 2x plus 1. I already know just because I've done that problem a lot. But you FOIL, go ahead and FOIL x plus 1 times x plus 1. You'll get this quadratic. If we keep adding, what we get is 2x squared plus 2x, and then the plus 1 and the 9. If we subtract 9, we'll end up getting minus 8. If we combine all of our like terms, and then all of that is going to equal 0. You can see that, hey, we've got a common denominator here. We can divide everything by 2. So that's going to cancel, that's going to cancel. And then what we get is x squared plus x minus 4 is equal to 0. And this is where our problem comes in. X squared plus 4 plus x minus 4 is not factorable. There is nothing that times itself will equal -4 that will add up to positive x. So we know we have to do something different. We're either going to have to use a complete the square or a quadratic formula method. I like quadratic formula because that saves us some time. But what is the quadratic formula? Well, you should have it memorized. It is -b plus or minus the square root of b squared minus 4ac all over 2a. Quadratic formula. So let's start plugging things in here. A is going to be positive 1, b is going to be positive 1, c is going to be -4. So if I rewrite this, I'm going to have -1 plus or minus square root of 1 squared minus 4 times 1 times -4 all over 2 times 1. All right, so let's simplify this, and then that'll give me my roots. We'll start with this radical. 1 squared is going to be 1. -4 times 1 is -4. -4 times -4 is 16, positive 16. So in the radical, I'm going to have the square root of 1 plus 16, which is going to end up being 17, right? So, and then that's just going to become -1. So in the numerator, I have -1 plus or minus square root of 17 all over the denominator of 2. Now, this is the value of my x, which can be difficult because now I have to find out my y. And then this is two different values of x. So what will happen is this plus or minus is the two different values of the x. One will come over here, and then we'll have, for x, we'll have -1 plus square root of 17 over 2, right? The y will be unknown. And then the other one comes over here, and the x value is -1 minus square root of 17 over 2. And then the y we still don't know yet. So these are our I'm tongue-tied today. These are our irrational roots. Man, that's a tough sentence to say. These are our irrational roots. Okay, so these are the x's. Now I have to solve for the y's. So I'm going to go back up to this equation. Y equals x plus 1. So all I have to do is take this equation and add 1. Now this becomes easier if I rewrite this irrationally, because then all I have is -1/2 plus or minus square root of 17 over 2. That makes it a lot easier to add 1 to, right? So if y is equal to this plus 1, -1/2 plus 1 is just going to become +1/2. And then the plus or minus is going to change depending on what the radical is. So if I were to add 1, the y is going to be +1/2, or 1 plus root 17 over 2. And then here the y is going to be +1 minus root 17 over 2. And those are my x and y values. So these are how you do irrational roots. You're going to have to use the quadratic formula, and then you use substitution to find out what the y value is. And it's not really going to be very difficult. You usually end up changing this lead fraction. Very rarely will you ever have to change the second radical, or the irrational number. So it's not too difficult. If you have any questions, let me know on Moodle, and I will see you in class.